Hello everyone, welcome to Matrices in our tutorials. In this tutorial, I'm going to talk about using apply function to matrices. The apply function has following syntax here. The first argument of the function is a matrix. The second one is either row or column. If it is a row, then the second argument is 1. If it is a column, then the second argument is 2. And third argument for the function is the operation that we want to do. So let's create a matrix first of all, and before that we have created a vector x, and we then create a matrix M out of this vector x with 3 rows, and the matrix is created here row wise because I have set the option by row equals to true. So let's see our matrix. So you can see we have 3 rows and 5 columns in the matrix M. Then we can apply the function here to calculate the sum of the elements of the row. Okay, so again, to remind, this is the matrix and this is the row, second argument because it is 1, and third one is we want to sum the elements of the row. So let's see how much is the sum. So 57 is the sum of the first row, 54 is the sum of elements in the second row, and 36 is the sum of elements in the third row. Similarly, we can calculate for column because the second argument here is 2. So let's see. So we have 5 columns. So these are the sums for elements of the 5 columns. We can also calculate the product of elements in row and columns using the same function. So let's see the product for column, and see the product for, sorry, the first one is the product for rows, and second one is the product of elements in the columns. Let's calculate the mean and standard deviation using the function apply. So let's calculate the mean for the elements in a row. So this is the mean for all the elements in first row, this is the mean for the elements in the second row, and this one is for the third row. And we can apply the similar description for the elements in column, and also we can calculate the standard deviation of rows and standard deviation for the columns. We can also calculate the cumulative sum using the apply function. So the third argument here is the cumsum or the cumulative sum. So let's calculate the cumulative sum for the rows first of all. Okay, so let's see our matrix. How is our matrix? So this is our matrix. So with 3 rows and 5 columns. So we are adding this time all the rows and calculating the cumulative sum of the rows. But you can, if you see here, the cumulative sum is calculated, but the matrix here looks different than what we have here. So what happened in this case is the cumulative sum is computed row wise, but matrix are always created column wise by default. So what happened is, though there is a cumulative sum of the rows, but they are created column wise. So to get the cumulative matrix, we can simply transverse or flip the rows and column using this transverse function. Then we will get the correct matrix. So let's see once again. So we are adding the elements in each rows cumulatively. So let's see, 11 is the first element here, so that's good. Then 11 plus 1 is 12 here, and then 12 plus 9 is 21, which is 21 here, and 21 plus 18 is 39, so 39 here, and 39 plus 18 is 57, and so on. So we successfully created the cumulative sum matrix. But if you want to apply this function cumsum to the columns, then there is no any problem here, because the cumulative sum is computed column wise, and also the matrix is created column wise by default, so we don't have to flip the rows and columns this time. We can similarly calculate the cumulative product. So let's do for the rows, and then we have to get the transpose of that matrix to get the cumulative product matrix, which is this one now. But for column, this will simply give us the cumulative product of all the elements of the columns. Similarly, we can use this apply function to calculate square root, logarithmics, and exponential, etc., keeping in mind that the difference between the rows and column operations are little bit different, and we have to always keep note of that while using this apply function. Okay, so thank you very much for watching this tutorial.